Uh, Welcome everyone. So this is the problem solving session number 11 for the uh, polymer reaction slash process engineering. So, so I hope that this problem solving session will be helpful for you to solve your assignment number 11. So starting from the first problem, polyvinyl is valued in electronics for its which property? So we have been given four options right here: high thermal conductivity, low electrical resistance, excellent flame retardancy, and biodegradability. So polyvinyl molecules examples are shown right here in these illustrations, as you can see. So the general diagram or the molecular structure for the polyvinyl is two carbon atoms with all hydrogen atoms, and one of them being replaced by either an OH or a chloride. When the OH is present, it becomes polyvinyl alcohol, and when you have the chloride, it is the polyvinyl chloride. So in electronics, usually, uh, what are the kind of properties which we are looking for? High thermal conductivity is definitely not one of them because already electrical circuits temperature rises very high, and we do not want that heat to get conducted and passed on to any neighboring circuits. So next we have the low electrical resistance. Low electrical resistance can again cause problems because the electrical conduction between individual circuitry on the board itself can cause uh, flame issues. And the third is the excellent flame retardancy. Now, the polyvinyl are very good, excellent flame retardants. Why? Because, as I explained, whenever they burn through, they produce char, and because of that, the uh, further burning of the flame is stopped. So that's why the flame retardant property of the polyvinyl is very high. But this is only achievable when the amount of plasticizer which is present inside the polyvinyl uh, compound is low. Why? Because plasticizers are used in the polymer itself to make it more, workable in the sense like when you want to reduce the viscosity of the polymer so that you can easily mold it and work with it, we add more plasticizer into that. But because of plasticizers, the flame retardancy property of the polyvinyl reduces. So we do not want that. So at that time, we have to use a much more purer grade of the polyvinyl. So that's why we have to reduce the plasticizer content in that. Then biodegradability, biodegradable polyvinyl might be biodegradable, but it will take a lot of time. And because of the presence of chlorine and other groups also makes it much more tougher to be biodegradable. So excellent flame retardancy is the property we are looking for when we are using the polyvinyl in the electronics industry. Next, we have acrylics are commonly used in electronic displays for their which property. So here are the few properties listed. You can see UV resistance and weatherability, high electrical conductivity, biodegradability, and magnetic shielding properties. Now, acrylics are usually see-through glasses, as you can see in the illustration right here. So you can see how the glass pane is clear itself. So that clarity in the glass pane is actually very good for any kind of radiative resistance. So the UV resistance and the weatherability characteristics of acrylics are pretty good. Why? Because since UV rays are coming in at very low wavelengths, the acrylic glasses are able to dissipate them quite easily and refract the rest of the rays through them. And that is the exact reason why UV resistance is quite high. And weatherability. Weatherability means the effects of heat, humidity, and UV radiation. Any other properties also is quite reduced on the acrylics because they are quite tough and they are kind of inert whenever it comes to reaction with any kind of humid environment, UV resistance, or heat itself. High electrical conductivity. Unfortunately, no electrical conductivity is observed in the acrylics itself. It's quite low. So high electrical conductivity is not the property which we are looking for. Then again, biodegradability. It's quite difficult to degrade the acrylic itself. And then magnetic shielding properties. As such, acrylics do not have any kind of magnetic shielding properties. So UV resistance and weatherability are the property which we are looking for when we are going for the electronic displays using the acrylics. Humidity testing of polymeric samples is performed to assess which of their properties. So first is tensile strength and elongation properties. Presence of water inside a sample may not necessarily affect the tensile strength and elongation properties, as when the water enters between the interstitial spaces of the polymeric chains, such as the free volume is present inside, it might not as much affect the uh, tensile strength of the material itself. So, tensile strength and elongation properties are not much affected. Then, chemical resistance and solvent capability. Again, chemical resistance won't be affected because we are not changing the structure of the molecule itself. And then, thermal conductivity and the heat resistance. Thermal conductivity and heat resistance are not affected by the humidity. Then last is the moisture absorption and dimensional stability. This is one of the major factors which are assessed during the humidity testing. Why? Because moisture absorption can be a big problem. For example, you have polyamide 6, PA6 or nylon. Nylon absorbs water, so you cannot make any kind of product which will be any kind of product which is near water using nylon. For example, if you want to make water pipes, you cannot choose nylon because definitely the water will be absorbed by the nylon itself. And dimensional stability because when the water is absorbed by the polymer, it starts swelling. And that polymer swelling is actually not really good for the polymer itself. And it can make the polymer not perform well to its maximum potential for whatever application you're using. So that's why moisture absorption and dimensional stability are one of the parameters for the humidity testing for the polymeric samples. Next, we have natural fiber reinforced composite materials are gaining popularity due to their various advantages. Which of the following statements is true about the natural fiber reinforced composites? First is they exhibit lower strength and stiffness compared to synthetic fiber composites. So they actually can show similar kind of strength and stiffness compared like just like the synthetic fiber composite. So first statement is not entirely true. Second is they are primarily used in high temperature applications due to their excellent heat resistance. This is false because they won't be able to withstand high temperature applications because synthetics perform much better in that area. And third we have is they offer better impact resistance and are lightweight compared to traditional materials. This is true because natural fibers they are less dense than any of the synthetic fibers, so they are definitely lightweight compared to traditional materials. And since they can exhibit similar kind of strength and stiffness compared to the synthetic fibers, so they can also offer better impact resistance and at the same time being the lightweight compared to the traditional materials. Fourth, we have they have poor resistance to moisture and are prone to degradation in the humid environments. Again, uh, this is not true. So, because again, the composites can be made in such a way that they can build up the resistance to moisture, and degradation in humid environments is a problem for the synthetic fiber composites also. So, they offer better impact resistance and are lightweight compared to traditional materials. Then we have the dielectric constant of polymeric materials is utilized in various applications, including which property? So we have four properties listed right here. Insulation for high voltage cables, magnetic data storage, optical lens manufacturing, and semiconductor device fabrication. So where does the dielectric constant of polymeric materials comes into picture? Here is that insulation provided for the high voltage cables. So in insulation, what happens is that your material should have a high enough dielectric constant so that it does not break down and become conductive soon enough. Why? Because already the cables are carrying very high voltage. So insulation for high voltage cables is very important. Then second one is magnetic data storage. Now dielectric properties do not play a role uh, for the polymeric materials in magnetic data storage, since polymers, most of them are not magnetic in nature. Then third one is the optical lens manufacturing. Optical properties of polymers are definitely useful here, not the dielectric ones. And then last one is the semiconductor device fabrication. Semiconductor device fabrication, here one can argue that maybe their dielectric constant properties might be useful while making the coatings and other parts necessary for the fabrication. but the major use is only in the insulation of high voltage cables. So that one is the major one. Last one we have, what are some advantages of the metal filled polymers? So what are the advantages of metal filled polymers? Improved thermal insulation properties. Again, if you are filling polymer with metals, definitely the thermal conductive properties will increase, not the insulation ones. So first statement is false. Second is enhanced electrical conductivity. Yes, definitely. Since we are filling the polymer with metals, we will have more electrons for the conduction of the electricity. So that's why enhanced electrical conductivity will be there. And then increased flexibility and elasticity. No, this is false because the elastic part of the polymer itself will be filled with the metals. So that's why it won't be more flexible. It will be quite rigid and it won't be as elastic. And higher resistance to chemical degradation. Again, it is quite subjective that metals might or might not provide the chemical degradation or chemical the resistance to chemical degradation properties to the polymer itself. So the enhanced electrical conductivity is the only correct answer for this question. Uh, I hope you have already solved the problems for this week, and if you have any doubts, you can ask me. Uh, just for a reminder, next class will be the last class. So if you want me to conduct an extra class to go through all of the topics from the beginning or any kind of revision question answers Q&A session, we can have that also if you have any doubts amongst them.
We can have the extra class, sir.
Okay, so we'll take a look at all the questions starting from
Yes,
the
yes.
assignment one. Okay.
Now, is it? Can you explain more on dissipation factor and power factor?
Dissipation factor and
Yes,
dissipation factor, right?
dissipation factor and power factor.
Power factor. Yes. Yes. So the dissipation factor basically is related to the dielectric properties of the material itself. So the amount of dielectric loss is what is defined by the dissipation factor. If you were to look at the standard definition of that.
Yes.
So, with respect to polymers, as I said, the question itself, where it has been shown here, the dielectric constant of polymeric materials is used for various applications, including which one. So, there you can clearly see that the insulation for high voltage cables. Now, here the amount of dielectric loss of the polymeric material can be like useful in
Dissipation.
understanding the relation for that. And again, same related to that, we have the power factor itself. The relationship between the dielectric and the power are quite like uh, if you have seen the lecture notes itself, you'll be able to figure it out.
So it measures the material's energy loss, and factor represents the material's ability to store the electrical energy.
Store the electrical energy. Yes, exactly.
Right? Right.
Yes. Do you have a question like that in the assignment?
Yeah. Yes. So
Okay.
not I have just saw very few points. So
Oh,
I mean, your classes are very useful to find the answers.
Okay.
I have to anyway see only tomorrow is available. Last assessment also I couldn't assignment also I couldn't submit
Oh,
properly.
okay, okay. Oh,
That's why we are
okay.
busy with some other work.
Hmm. It's fine, man.
Thank you. And yeah, other questions I think I can add. So I have
Yes,
to
ma'am.
look into other. So 12 anyway. There is one more session is there, right?
Yes, ma'am.
Yes. So this
Uh,
the overall session when you can plan after the all the 12 weeks.
yeah, I think after the 12th week, I will plan that one. When is the
Yes, yes,
exam? Actually, you'll be
yes.
giving the exam, right?
We, we didn't get the hall ticket, ma'am. Reshmi, ma'am.
Yeah, actually, exam is the 26th. They have scheduled, sir. But hall
Okay,
tickets, I don't know whether any change in dates will be coming. As per the NPTEL site, no, it is on 26th.
okay, okay, 26. So
Yeah.
if it's on 26, then
Just one.
we can have a class on 22nd. Is it fine?
Yeah. Okay, okay.
So 15th one class will be there. That is the final
Because
12th class, and then 22nd one more class we will have.
okay, okay, okay.
So that will be much better.
So one more thing, yeah.
Yeah,
So actually, regarding last session, oh, I hope you remember we were discussing about the encapsulation of polyurethanes, no, sir?
yeah.
Actually, we went on conformal coating, but
Hmm.
the answer key which had come was coating, sir.
Coating, normal
So
coating.
actually, no, potting,
Potting.
P.
Okay. P.
Okay.
Potting. So I don't understand why. What is it? Why conformal potting won't be a wrong answer, no? Because in the
Yeah.
session potting, yeah, but we were given the 0 marks for potting, conformal potting. Instead, they have marked for potting, sir. So we haven't raised the query in that. So I think that can be relooked for valuation.
Okay.
Yes. So,
But I think conformal coating was the one because that is usually used for like
yes,
resistance
yes,
from
yes.
moisture.
Yeah, yeah. So my thoughting was because mine that alone answer was wrong. That's why I was very sure.
Okay. So like you
Because
have seen
I
the
was telling no because when the classes were took no
hmm,
sir was telling potting, molding, conformal coating all are encapsulation techniques. So
yes.
since all the answer came no because which one to select also we were not knowing. So
Yeah,
among them the best our understanding was conformal coating. But
conformal coating, yes.
valuation time, no, we were not given the mark.
Oh, like let's see if I can like I tried contacting sir and I didn't get any reply, but I'll try to contact once again for about that. Okay?
Yeah, thank you.
Yeah. Reshmi, you are also from the same ma'am, you are also from the same
No,
department, right?
No, sir.
Okay. Okay, then that's all there was for today's class. Like we can
yes.
only discuss these only problems. So if you have any other doubts, you can ask me.
Okay. Okay. Thank you. Thank you.
Yes.
Okay, thank you, sir. Then.
Yes, ma'am. Yes, ma'am.
Is it possible for me to give a phone number? Shall I
Yeah,
message
sure.
the phone number? Yes,
Yes, ma'am. I'll just write that in the chat box.
I'll also. I'll, I'll give my number. Once you
Yes.
come, you please call me.
Okay, ma'am.
can visit our labs.
Yes, ma'am, sure. I'll be there
Help us.
tomorrow.
Students also. Maybe you can meet our PD students.
Yes, ma'am, sure.
Thank you. Thank you so much.
Yes, ma'am.
Thank you. Bye.
Bye, ma'am. Bye. Uh, Hello everyone. Uh, Actually, the first session is over. A few of the students have already attended, so I will start the next session now. Good evening, everyone. This is the session number 11 for the polymer process engineering, and uh, few questions will be discussed, which will be helpful for you in your assignment number 11. So, starting with the first question. We have polyvinyl is valued in electronics for which of its properties? So here we have been given two of the illustrations for polyvinyl. What does the polyvinyl group look like? So first one is the polyvinyl alcohol, where you can see there is carbon-carbon bond with the hydrogen on the three sides, and on the fourth one we have the OH group, that is the alcohol group. So this is the polyvinyl alcohol. And then the right hand side we have the similar group but replaced with chlorine. So this is the polyvinyl chloride. So what is the use of these? One second. So polyvinyl is valued in electronics for which of its properties? So in these two illustrations, we can clearly see how does the polyvinyl group looks like. With the OH one, we have the polyvinyl alcohol, and on the right hand side, we have the polyvinyl fluoride. So high thermal conductivity. Since it's a polymer, it will not have high thermal conductivity, and that is not the property which we are looking for in the electronics. And second one, we have the low electrical resistance. Again, this is not the property which we are targeting, because a low electrical resistance means that uh, conductivity will be very high, and we do not want that in any kind of electronic equipment. And then the third one is the excellent flame retardancy. Definitely, polyvinyl products can have excellent flame retardancy, but it depends on the amount of plasticizer which is present inside the polyvinyl compound. Why? Because the plasticizer actually reduces the flame retardant properties of the polyvinyl compound itself. So if you want excellent flame retardancy, it is better to use purer compounds with the polyvinyl. But plasticizers are added to reduce the viscosity of the polymer itself and to make it more moldable and workable. So even though it has its advantages, it somehow degrades the properties of the polymer itself. So that's why uh, pure polyvinyl will have excellent flame retardancy. Biodegradability again is not a parameter which we are looking for. We already know that it's quite difficult to be biodegradable, but at the same time we can recycle it. So that is one plus point of that. So excellent flame retardancy is a property which we are using for the polyvinyl electronics. Then next we have the acrylics are commonly used in electronic displays for their which property. So we have been given four options right here: UV resistance and weatherability, high electrical conductivity, biodegradability, and magnetic shielding properties. Acrylics, as you can see right here in the illustration down below, they are quite transparent glasses, and they're used in the electronic displays for their UV resistance and weatherability. Why UV resistance? Because acrylics have the refractive index of acrylics are quite low, and the wavelength for the UV radiation is also quite low. So the amount of refracted and the reflected components of the UV rays gives it the high UV resistance properties. And since it's acrylic, it's quite robust, and that's why it is able to withstand humid and heat conditions. And that's why the weatherability properties of the acrylics are quite high. High electrical conductivity is not a property for the electronic displays. So high electrical conductivity is not the answer. Then biodegradability and magnetic shielding properties are again not associated with the acrylics. So UV resistance and weatherability are the properties looking for the acrylic compounds. And third one is humidity testing of polymeric samples is performed to assess their which property. So humidity testing is actually it takes a lot of different parameters to test the humidity performance of a polymer sample. So the tensile strength and elongation properties. Tensile strength and elongation will get affected because of presence of humidity, but not to that much of a high degree. Then we have the chemical resistance and solvent compatibility. Chemical resistance and solvent compatibility do not fit in the humidity testing regime of the polymeric sample. So that is not the answer for this. Then thermal conductivity and heat resistance. Again, these have different tests, and humidity is not one of them. Moisture absorption and dimensional stability. Definitely, moisture absorption is a part of the humidity testing, and we are always testing how much the polymer is absorbing the water. For example, one of the best examples is the nylon or the PA6, which actually readily absorbs humidity and water. So if you were to design any kind of product for the outdoor usage or any kind of place where the humidity is high, you definitely will think twice before selecting nylon or any other material which will absorb humidity like that. Then dimensional stability. Because of absorption of water and the humidity itself, the polymer can undergo swelling because of presence of water molecules. And that is the exact reason why dimensional stability of the material might not might not be that good, or might not be that robust, because once the humidity is absorbed by the material itself, it might undergo some kind of dimensional instability. And that is the exact reason and the exact parameters with which we are humidity testing the polymeric samples. So moisture absorption and dimensional stability. Next, we have the natural fiber reinforced composite materials are gaining popularity due to their various advantages. Which of the following statements is true about the natural fiber reinforced composites? First is they exhibit lower strength and stiffness compared to synthetic fiber composites. This is not entirely true. They do show quite formidable strength and stiffness in comparison with the synthetic fiber composites, very close to it, if not equal to the synthetic fiber ones. Then the second one is they are primarily used in high temperature applications due to their excellent heat resistance. No, they do not have high temperature applications because they won't be able to withstand the uh, thermal effects as well as the synthetic ones do. So that is false. Third one is they offer better impact resistance and are lightweight compared to the traditional materials. Now, this is very true because natural fibers are actually lighter than the synthetic ones. So that's why the composites definitely formed by that are lightweight compared to the traditional materials. They offer better impact resistance. So, as I said in the first point, they exhibit all slightly lower or maybe equal strength and stiffness compared to synthetic fibers. So that's why they can give better impact resistance also, uh, uh, in addition to being lightweight. They have poor resistance to moisture and are prone to degradation in humid environments. They can have poor resistance to moisture and prone to degradation in humid environments, but that depends upon with what material you are making the matrix of the composite itself. So there are many parameters which are associated with that. So third one, that they offer better impact resistance and are lightweight compared to traditional materials is true. Also, poor resistance to moisture and prone to degradation in human environments can also be true with respect to that. Then we have the dielectric constant of polymeric materials is utilized in various applications, including which property or which application. So we have been given four applications here: insulation for high voltage cables, magnetic data storage, optical lens manufacturing, and semiconductor device fabrication. So Since the dielectric constant of the polymeric materials is high, which means that to make it conductive, a lot of electricity or high voltage is required. And that is the exact property which we are looking for when we are trying to form the insulation of high voltage cables. So that's why polymeric materials are best suited with the high dielectric constant in that case, in that application. Magnetic data storage, polymeric materials with these kinds of dielectric constants are not exactly magnetic in nature, so they do not serve any purpose in that place. Optical lens manufacturing is more concerned with the optical properties of the polymer and not the dielectric constant. Semiconductor device fabrication can utilize the dielectric constant of the polymers in some kind of coating or some other form, but not as much as the insulation of high voltage cables. So, insulation of high voltage cables is the main example for that. What are some advantages of the metal filled polymers? So we are looking for the advantages. Improved thermal insulation properties. Improved thermal insulation properties is not exactly an advantage because polymers inherently are insulators of heat itself, and by adding metal to that, we are making it more uh, susceptible to heat. So the thermal performance might degrade. Enhanced electrical conductivity. Yes, that can be an advantage, and that is one of the advantages of adding metal to the polymers itself. So if you have a metal complex formed with the polymer, it can improve the electrical conductivity of the polymers, and if any application requires that, that will be useful. Increased flexibility and elasticity. No, it won't be increasing the flexibility and elasticity, and it's not an advantage because it will be making the polymer weaker, much weaker, since it is more flexible and elastic. Then higher resistance to chemical degradation. That is subjective since the polymers and the metal formed compound itself won't be exactly having the higher resistance to chemical degradation compared to the base polymer itself. So enhanced electrical conductivity is the only advantage of the metal filled polymers. Uh, Hello, Prashant. Uh, so yeah, these are the only questions for today's session. Uh, Next session will be the 12th session, and that will be the last one.
Okay, sir.
Yeah, and after the 12th
So
session,
maybe next week maybe I will be busy somewhere, so maybe I'm not able to attend that.
no, it's
But I'll
fine. You
try.
can, yeah, it's fine. No problem. And one more thing is that after the 12th session, after that, I will be conducting one extra class where I will discuss everything from the first assignment. Okay? Questions from,
Okay,
it's like a recap class just before the exam.
okay. Recap and just hint like practicing for exam,
Yeah,
do and
something like
don'ts
that.
regarding.
Exactly,
Okay,
exactly. Yeah. That's all there is to it for today's class. Uh, if you want, you can leave. You don't have any other.
okay, sir.
Yeah.
Okay, sir. Thank you, sir.
Yeah.